Okay, so in this chapter, we are going to generalize standard normal distribution to any normal distribution. But actually, what we are going to do is we are going to make any normal distribution into standard normal distribution using the standardization process. So we fixed the mean at 0 and the variance at 1, but what if we have a normal distribution with different parameter values? The idea is we standardize them so that they have mean 0 and variance 1. That is our approach. So we are going to standardize, and to do that, we need to recall these properties. So mean is a linear if y is a linear transformation of x, then the mean of y is also linear, and the variance is weird, but the standard deviation is multiplied, but is not affected by addition. Okay, so what's interesting here is mean is nice and standard deviation is not affected by addition. So combining these two properties, we get a very nice simple result. Like for example, if x is normally distributed, and then another amazing property of the normal distribution is that a linear transformation of normal distribution is also normal. This is not true for many other distributions, like binomial distribution. It does not work. Binary, of course, does not work, and many other distributions do not allow this kind of seemingly obvious result. Seemingly obvious property is actually very rare and precious property. So, like we are going to use these results that we learned earlier, and a new result. Normal distribution preserves linearity, linear transformation, that is also used. Combining those, what we have is assume that the original distribution x is a normal distribution, but it does not need to be a standard normal distribution. Then, if you take a linear transformation of that, like this, then y follows another normal distribution, right? This is the property of a normal distribution, and the mean and the variance parameters are given by these properties. Okay? And what we want here is we want to make this new transformed random variable a standard normal distribution, right? So we want to choose A and B so that the mean and the variance equal to 0 and 1. Then you can always transform any normal distribution into standard normal distribution. How do you choose A and B? The answer is like this, right? First, if you choose A as 1 over sigma, the divided by the standard deviation, then variance, if you plug that into here, then sigma's 1 over sigma squared cancels out sigma squared. So variance becomes 1. And if you choose B as minus mu over sigma, then expectation becomes A times mu is mu over sigma, right? 1 over sigma is multiplied to mu. And then you subtract the same thing. So it becomes 0. That is, this form, if you define y like this, x minus mu over sigma, then this y always has mean 0 and variance 1. So we know how to handle that. That is standard normal distribution. That is the standardization process, right? Z, we are going to, as we promised, we are going to denote this guy as the standard normal distribution as Z. So usually we write Z equals x minus mu over sigma. Standardized normal distribution, right? Then you may interpret Z as like this, z measures how many standard deviations x deviates from its mean, right? Right? So x minus mu is the distance between x and the mean, and you divide it by sigma. So you rescale the unit into standard deviations. Okay? So for example, if z is, for example, -2, that means a realization or random variable x is 2 standard deviation below its mean. That is how you interpret the standardized random variable. Then it has many nice properties. As x increases, z increases too, right? That is like, so it is linear, so it is, the slope is going up. And if x is above its mean, then z is positive. Positive z means it is above the mean, and negative means below mean. Okay? Then, okay, idea is clear, idea is simple. Then how can we use that? Oh, excuse me. I'm still coughing a lot, so I need to take another throat candy. So, suppose that you want to calculate this CDF. Basically, if you know the CDF, you know everything about x. So x is given this way. And then x is non-standard normal distribution. How can we transform this into standard normal distribution so that we can utilize the properties of standard normal distribution? First, you know how to do that. We are going to transform x into z by subtracting mean and dividing by the standard deviation. But what you have to remember is you have to do the same transformation on both sides, because you have to keep the inequality, right? If you subtract mu to keep the inequality equal, like unchanged, to keep the inequality unchanged, you have to subtract mu again on the other side too. So in the same way, like, you have to maintain the inequality by doing the same thing on both sides. And then left hand side becomes the standardized z. Right hand side is what you need to calculate. Okay? And then this is standard normal distribution CDF, excuse me. So calculate this number and plug that into the standard normal distribution formula on Excel. That is what you are going to do. Okay, the point here is you have to transform both sides. That is a typical mistake many students forget. Okay, so let me think about a real example. Suppose that x is the life of a tire in mileage. So I'll assume that a tire lasts. The life of a tire is normally distributed with mean 35,000 miles and sigma 5,000 miles, for example, right? So some tires last longer, other tires last shorter, like does not last that much. So in this case, I was wondering, what is the probability of tires that worn out before 40,000 miles, right? This is what we would like to calculate. I have driven like 40,000 miles. Is my tire okay or not? That is the question, okay? Then, following the idea, first remember, like, we know the mean and the variance, mean and the standard deviation of this random variable. Original random variable is tire life. That is non-standard normal distribution, and we would like to calculate non-standard normal distribution's probability. How can we do that? Standardize. We are going to standardize x. That is automatic. That is mechanically standardized. But your job is to standardize the other side. We know in the end x will become z. That is not a problem. We know the ending. but 40,000 should be transformed, and that's what you need to calculate. So you have to subtract mean and divide by standard deviation on the right hand side too, as you did on the other side. So, and you know these numbers, then you get this number on the right hand side, which is 1. Then from here, you know, you can take this number, that is 48%, 84% is the answer, right? So you can just use standard normal distribution, CDF, to calculate this probability. Non-standard normal distribution is calculated using the standard normal distribution. Okay? So then, I will ask you another similar question. It is your turn. Calculate the probability that a tire is worn out before 32,000 miles. Same structure. Everything is the same, just different numbers. Try it by yourself. Okay. This is an important practice because we are going to use normal distribution all the following chapters. So you have to practice how to calculate probability here so that we can use that skill in the next chapters. Okay, let me show you the answer. Idea is the same. You are going to transform, standardize x into z. So you have to standardize 32,000 miles in the same way. Subtract the mean and divide by standard deviation 5,000. And then you get minus 0.6. This means 32,000 miles, if your tire is worn out at 32,000 miles, that means it is 0.6 standard deviation below the average life, right? That's the meaning of this. If you relatively rank tire lives, it is below the average by 0.6 standard deviation. That is the meaning of this standardization. But anyhow, what we are doing here is more like algebra, simple algebra. So plug that into Excel. Like I will use norm s dot dist minus 0.6 and cumulative is true. And you get 27.425%. Right? That is how you calculate normal distribution. Okay. Next, now let's see how you calculate. So far, what was simple is after transformation, after standardization, you get a CDF, probability smaller than something. Probability smaller than something is exactly the CDF. So it was easy to calculate. But what happens if you want to calculate probability greater than something? So now let's calculate probability greater than 30,000 miles. Okay. In that case, idea is the same. We are going to standardize the random variable x into z. We know that. So do that. So standardize x and also standardize right hand side. Now you get minus 1. So 30,000 mile is 1 standard deviation short of the mean, the expectation. So this is standardized probability. But the problem is, it is not in the form of a cumulative probability. It is probability greater than minus 1. But what we want is probability smaller than something. So how do you convert? Probability greater than minus 1 is the other side, flip side of probability smaller than minus 1. So 100% minus cumulative probability will give you probability greater than something. So you need this step, this conversion, to obtain cumulative probability. And then now you use Excel to calculate this probability about standard normal distribution. We did it earlier. So we obtained 84.134%. Okay, so the idea is clear. We are extending our steps. First, we learned CDF can calculate anything. If you have probability greater than something, take 1 minus the cumulative probability, right? And then we learned how to use standard normal distribution. And then now we add another step, how to standardize non-standard normal distribution. So combine all these three techniques, then you can calculate probability of this form. Okay. Okay, then your exercise again. Try it by yourself using Excel. What is the probability that tire lasts more than 37,000 miles? Everything is the same. If you don't know how to handle that, go to the previous slide and just follow what I did with different numbers. Try that. Okay. So the answer is like this. First step, standardize both sides. That's the point. Then you get z greater than 0.4. Greater than 37,000 is greater than 0.4 after standardization. But again, this requires conversion. So the direction of the inequality is it is not desired. So you take 1 minus probability, cumulative probability. This is the probability you can calculate from Excel. So Excel, you calculate that, you get this number, right? Let me show you. Probability .4, true. So you get, excuse me, this probability. So from there, you can calculate probability greater than 0.4. So you need 3 steps to do that. Okay. Okay, then the next form of probability we are going to practice is on interval. What is the probability between 30,000 and 40,000? Okay. Idea is the same. First standardize, then you get a probability in terms of standard normal distribution. That is nice. But what is not nice is it is not in the cumulative probability form. So you have to convert this probability using express this probability using cumulative probabilities by taking difference of 2 cumulative probabilities. Okay, and then use Excel. Enter these numbers, put in these numbers on Excel, and obtain those numbers. Okay, then each step it is simple algebra, and you know how to calculate them. Remember, so in here in standardization, you have to standardize all 3 terms. When you standardize x, you have to apply the same procedure on left hand side, of course, and on the right hand side too. Right? So so that both inequalities remain unchanged. Okay. Then it is easy. So between plus minus 1, then you have to calculate cumulative probability at 1 and minus 1, and then take their difference. So use Excel twice and take their difference to calculate the probability in the middle. Right? In the middle, there is about 68% probability in between plus minus 1. Again, your turn. So try this question and continue to the next video. Next video will be the last one. So finish this question before turning to the next one. Okay? See you in the next video.